Hello, Prop Stats, and welcome to Chapter 8. This is all about hypothesis testing. So you're going to create a hypothesis and see if you're correct or not correct. And we'll use different means, or different methods, I should say, because one of them is the mean. We'll use the standard deviation. We will use the proportion, all three. The first section is just general, like what are the 8 steps you have to follow, and then the next 3 are each one of those individually. So make sure you have stat disk ready. All right, we're going to identify the null, which is the null and the alternative hypothesis. The null is your statement that is the equal sign, and then the alternative is the non-equal, which we'll talk about in a little bit. We'll talk about a test statistic, a critical value, and p-values, because there are different ways to see if you're correct or not correct. We'll make statements with the null and the alternative hypothesis. We will do graphing. We will test the statistic, we will identify a p-value or the critical value, and we will make a conclusion rejecting the null or failing to reject the null. And then we'll do a general one that actually deals with the data we're using. Whoops. Okay, these above 6 items are required. There are actually 8. I shouldn't have said 6 here. That will be graded because there are 8 steps and everybody's worth 4 points. And I hope you do well. Don't forget all 8 of them. There's actually 8 of these. Okay, hypothesis is a claim or statement about a property. So this is what I am claiming is going to happen. The hypothesis test is a procedure for seeing if my claim is correct. And we'll use StatDisk to do all of this. All right, here's an example. The majority of consumers are not comfortable with drone delivery. So this is what I am claiming. All right, so we have 1,009 consumers. So this would be known as our N, how many people we have. We're asked if they are comfortable with having drones delivered their purchase. 54%, or 545 of them, so this in here is dealing with a proportion, they don't have to be, responded with no. Okay, use P to note the proportion of consumers not comfortable with the drone and the majority claim. So this majority right here means that it has to be over 50%, and that's all that means, nothing more. So let's go through here. We have the claim that the population proportion P, that's what we're going to call it, is such that it's over 0.5, all right? Among the 1,009 consumers, how many do we need to get a significantly high number to say we're true or false? Okay, the result of 506, or 50.1 when you calculate it, is just barely more than half. So 506 is clearly not good enough, right? If we had 1,006, that's 90%. That's really significant. What about this 54 that we have? All right, sorry about that. Is it significant or not? It's too close just to tell. So we have to do hypothesis testing. All right, when we do this, we're going to be in StatDisk, and it says hypothesis test proportion 1 sample. So you're going to get there by going, here, let me demonstrate. So you're going to go to analysis, hypothesis testing, and then there's different kinds. We'll be doing the 1 sample. We'll either do proportion, a mean, or a standard deviation. Now, this one that we're doing to demonstrate the 8 steps is proportion, but all 3 will be covered in this chapter. So remember analysis, hypothesis testing, then which one of those 3 are we using? Okay, back to notes. All right, now here we have to enter what our claim is, and our claim is the population proportion is bigger than the claim proportion. So I'm going to say it's over 54% or 50%. I want to do a 0.05 significance level right here. 50% is what I'm claiming. My sample size was 1,009, and the number of successes, so the people who said they did not like this, it's not necessarily true or false, it's just what we're looking for, was 545. Okay, now when we type this in, we'll get a sample proportion, a test statistic, a critical Z, a p-value, and a confidence interval. We will be using all of these for testing because each one of these will give us a different, well, actually most of the time the same result, a few times different, but they tell us if we are correct or false. Okay, we're going to focus on the test statistic this time. So my test statistic, it's hard to say, is 2.5500. My p-value right here is 0.0539. Okay, both of those are going to be good indicators if we're true or false. Okay, the hypothesis test also tests significance. Okay, we used a probability to determine when sample results are significantly low or significantly high. And this is going to help us decide or formalize this when we're using our things. All right, a null hypothesis, all right, very important to understand. Okay, it's always H sub 0. That is its notation. And it always has an equal to sign in it. All right, so the null hypothesis is that it equals 0.5. Regardless of what we're choosing, the null is always the equal. All right, the alternative does not have the equal in it. So now we said our alternative this time was greater than 0.5. That's H sub A, alternative hypothesis, H sub 0, null hypothesis. Make sure you have your notation correct because we will be using those all the time. All right, these are the steps you have to follow. All right, so there are truly 8 of them. Identify, what are you actually trying to prove? So, what am I claiming? Okay, make sure you write in symbolic form. That's where you're using the P. All right, P is either greater than, or P is less than, or P is greater than or equal to, whatever it is, but you're using this P. Identify the null and the alternative. So you have to create the alternative hypothesis and the null hypothesis. Step 3. You have to identify your significant level. So what does alpha equal? Is it 0.05? Is it 0.01? Is it 0.1? Whatever it is, what is your significant level? Make sure you identify it. So that gives us very different results. Identify the test statistic. So when this will come from StatDisk, it will give it to us, but we have to look at it. Now, there are different methods to using the test statistic. We can either use the p-value, or we can use the critical value, or you can do both to check yourself, which is usually what I do. So you do the p-value, and we check to see if the p-value is less than alpha. Right down here. Find the test statistic is first of all. Now we check right here. We reject the null, the p-value is less, and we fail to reject, the p-value is greater. On the test statistic, first you find that, that's also from StatDisk. Reject the null if it is in the critical region, and we fail to reject if it's not in the critical region, which is drawn by a drawing. We'll show you that later. After you have rejected or not rejected the null, you must restate. What does this mean with what we're talking about? You can't just say we reject the null. You have to say we reject the fact that it is over 50% or something on that order. In this case, it would be drone delivery. So we would say we reject the fact that over half the population does not like drone delivery or something on this order. We'll give you this in a little bit. Okay, confidence intervals, 0.01. There's called a two-tailed test and a one-tailed test. Almost all of ours are one-tailed. They're almost either left or right. And we'll see that in a little bit. But there is a two-tailed test. That's when it divides it up. Okay, confidence interval. A population parameter contains a likelihood the values of the parameter are in there. We reject a claim that the population parameter has a value that is not included in the confidence interval. And this is true like all the time. Sometimes it gives us a different result when we're using proportions, but we'll talk about that later also. All right, here's an example. Drone delivery, these are the steps you must follow, all right, to get all your points. So step 1, litter them, label them, identify the claim. What are we saying is happening? And we're saying P is greater than 50%. Okay, if the majority is uncomfortable with drone delivery, which is P is greater than 50%, which is actually step 2. I need my symbolic, all right? That means then is false, then P is less than or equal 0.5 must be true. So since this has the equal in it, right here, this is our null. This is our equal, P equals 0.5. Then our alternative, our H1, our H sub A, is P is greater than 0.5. This is what we will be testing. What significance level do we want? And if it does not tell us, we use 0.05. All right, common choice is 0.05, 0.01. We're going to use this if it's not stated. So we've got 4 done. Now we're up to 5. We have to identify what we're going to use. So are we talking about a proportion, which is a z-score, a mean, which is our t, or our standard deviation, which is our chi-squared? We don't think we ever have one where we know the standard deviation, so it's usually one of these. Now when we go through, we're going to use StatDist to actually calculate these. We just have to know which one we're actually using. Here we go. Oops. All right, drone deliveries. Whoops, come on, here we go. Okay, we have 0.5 is the claim. We have n equals 1009, so how many people did we survey? We have p equals 0.5, that is my true ones, and q equals 0.5. That's just my false ones. Remember, it has to be a normal distribution, which it is, and they both have to be greater than 5, which they are. So our requirements are met. Okay, find the value of the test statistic and the critical values, the p-value or the critical values. All of these work, and this is all done on StatDisk. We will not do any of this by hand. Okay, when we do the test statistic, you're going to be looking at which one of the 3 you use. So is it a proportion, is it a mean, or is it a standard deviation? All right, so you just identify the one that goes with what we're testing. Okay, the drone delivery, population P, it was a 0.54. All right, so we had 1000 N, X equals 554, and we're going to use our StatDist to calculate our stuff with this. Our null hypothesis is P is equal to 0.5. We're working with the assumption P equals 0.5, and Q then is 1 minus, which is also 0.5. The test statistic from StatDisk is 2.55. Now let's show you what this all does. Okay, we have a critical region, and we'll show you that in a little bit. We'll actually draw pictures. It's a two-tailed, a left-tailed, or a right-tailed. Almost all of ours are going to be left or right-tailed, but a two-tailed means there's 2 parts which are bad. If it falls in here, we reject the null. Left, if our value falls here, we reject the null, and right, if our value falls in this section, we reject the null. And this will make more sense with numbers. And we will be drawing these stats. Okay, hypothesis test, the p-value is the probability of getting the value of test statistics that is at least as extreme. All right, so at least as extreme, assuming that the null hypothesis is true. Okay, here we go. Using the sample data, okay, we have a test statistic of z equals 2.5. Normal distribution, 0.0054 to its right, so a right-tailed test. All right, our test statistic is 2.55, our p-value is 0.054. All right, now if we use our technology, so what kind of test are we doing? Is it a left or a right-tailed? And ours is right. We can do the p-value, and the p-value equals area to the right, so right here. So if it falls in here, then we have to reject the null. So this part is bad. All right, critical value works the same way, except you'll have a critical value here, and you'll also have a test statistic that will plug in, and if it falls in here again, it is bad. Okay, now let's show you some of these. Okay, we have to make a decision. If the p-value is less than this, we reject the null. So if the p is low, the null must go. All right, if the p-value is greater than our significance level, we fail to reject the null. So we can't say it's false. Okay, drone delivery. We have a p-value of 0.05, which is less than 0.05. This means we reject the null hypothesis. Remember, the null was it equals 0.5. Okay, remember our null was p equals, whoops, equals 0.5. So we're rejecting the null, which says that was what our statement was. So since p-value of 0.05 suggests that we reject the null hypothesis, that 50% of the people do not like getting drone delivery. So this here is false. All right, so we're rejecting that 50%, but now we have to restate what this actually meant. So we said that our alternative was that the majority don't like. So since our null is false, we get to accept our original statement. There is sufficient evidence to support the claim that the majority of consumers are uncomfortable with drone deliveries, is how we would state that. And here are some things to help you write these because it is a little bit confusing. Original claim does not include equality. You reject the null. There's sufficient evidence to support. Original claim does not include equality and you fail to reject the null. There is not sufficient evidence to support. The original claim includes equality, so now you're accepting the null, and you reject the null. There's sufficient evidence to warrant rejection of the claim, because now your claim is the null, right? Because the equal is the null. And last, original claim includes equality. You fail to reject it. There's sufficient evidence to warrant rejection of the claim because now your claim is the null. I know, kind of weird, but you'll get it after we go through, after you write enough of them. All right, we're going to explore our data about dogs. Now, when I did this, you had not taken this sample survey yet, so we had to make some things up. But we can still do quite a bit of it. All right, number one, use our data. We want to claim that the majority, so let's look what we're doing. We are claiming the majority of students prefer dogs. All right, so our claim, and remember we've got to write this in P, and majority is greater than 0.5. This is our claim. P to denote statistics, we always use P. I'm going to use a 0.05 significance level. If we should reject the null, use p-values instead of critical values. We'll probably, p-values are just a little easier. Critical values also work. So step one, we are going to claim that the majority, oh wait, this is yours. Okay, pause and try this. All right, let's see how you did. First thing we have to do is majority of students prefer dogs. So that means P has to be greater than 0.5. The opposite is P is less than or equal to 0.5. So then our null is P equals 0.5 or 50%. And our alternative P is greater than 0.5. We have a 0.05 is our significance level. And now we have to do our test statistic because this is a proportion. All right, so I made this stuff up, but let's go to StatDisk and see what happens. So probability, hypothesis testing, and we're going to do proportion of one sample. So our significant was 0.05. We are going to claim it's 50%. Oops, I forgot to do the top. My proportion is, it's greater than the claim. It's my alternative. My sample size, there were 53 of you. And then I pretended that 31 of you prefer dogs. Then you hit evaluate. Okay, now you write down these numbers and we've got a sample proportion. We're not using that yet. Our test statistic is 1.23, our critical value is 1.6, and our p-value is 0.18. We will also use this confidence interval later on. So now we go down here and let's show you what this actually does. So we plugged it in. Now if we're going to use the test statistic and the critical value, all right, so these two here is one way to evaluate. So now we draw our graph and we put in our critical value of 1.64, which is right here. Then where does our test statistic fall? Now if it goes to the right, if it falls in here, we reject the null. If it's to the left of that test statistic, then we fail to reject. Well, our statistic was 1.23. Okay, this is to the left, which means we fail to reject the null. The other way to use it is with our p-value. So there's many ways to test this. The other one's going to be our confidence interval. Our p-value, now we check, is the p-value is greater than 0.05. So since that's true, we also fail to reject the null. So there is not, oh my writing went away, not sufficient evidence to support the claim that, whoops, over 50% of statistics children prefer dogs. It's not true. If you actually did this here, it would have to be, I think, about 32 or 33, and then there is sufficient. But according to this, it is not true. Okay, now confidence interval is the next way we can use. If you look, that was a bottom number in our things. A proportion and the confidence interval do not always give you the same result. All right, a mean always does and a standard deviation always does. So these, no matter what we use, we will fail to reject or not fail to reject the null no matter what, but not true of a proportion. Okay, now there are different types of errors here. There's a type 1 error and a type 2 error. Okay, type 1 error is when, right here, type 1, you reject the null when the null is true. Okay, a type 2 error is you fail to reject the null when the null is false. So you reject it when it's true, type 1. You fail to reject when it's false, type 2. So these are two types of errors that can happen when we're doing this. All right, consider this and see if you can figure this out. Write down what you think it is. Pause and give it a shot. All right, if you looked down below, I actually wrote the answers. Type 1 error is mistakenly rejecting the true null. So, in this case, type 1 is to conclude that the medical procedure is effective when in reality it had no effect. Type 1 error. Type 2 error, conclude that the medical procedure has no effect when in reality it actually did affect it. Those are your type 1 and type 2 errors. I hope you did well with that. All right, good luck on your homework. I hope you do well. Make sure you post questions.